Okay, let's discuss how to do a normal distribution. Trying to find the probabilities of a normal distribution on the TI graphing calculator here. I'll do another video for the TI 36X Pro, but it's really similar. Alright, so to find the probability, we're going to be going into distributions. So you'll hit second key, and then you're going to go into distributions, it says right there. And we want to use the normal CDF. We're always going to be using the normal CDF. Unlike when we were doing binomial distributions, we used both the PDF and the CDF. Here we're just going to completely ignore the normal PDF for this class. So we just use the normal CDF. We'll go there. And what this is going to be, you're going to do your left, your right, your mean, that's a weird looking mean, and your standard deviation. So that is to say, if we had a normal curve here, in general we're trying to find the area between two things. This is going, when I say the left, that's this one over here, the lower, sometimes lower and upper, sometimes what they're called. Left, right, your mean and your standard deviation. Of course, you're going to get those from your problem. So if I wanted to say if mean equals 0 and standard deviation equals 1, find the probability that z is less than or equal to negative 1.23. Actually, I'm going to hold off on doing less than or equal to. I'm going to say between two values first. Let's say the probability that 0 is less than or equal to z, which is less than or equal to 1. The probability that we get a value between 0 and 1 here, that's what I'll do first. So this would look like this. We have a 0 and we have a 1. We're trying to find the probability that we're between those two values. So I'll just pull out my calculator. The left bound is 0, the right bound is 1, and my mean is 0, my standard deviation is 1. So I'll enter all that stuff in there, press enter, and we get a probability of 0.3413. If I wanted to find the probability of an unbounded, if I wanted to say it keeps going forever to the left or to the right, what I need to now say is, if you want to find the area to the left of a particular value or to the right of a particular value, then this calculator, well, you still need to enter a lower or an upper bound. So let's first think about how we would do to the right of a particular area. So let's say if z equals negative 1.23, we wanted to find the area to the right. Well, the region we're talking about is right here, and so this z equals negative 2.3 is the left bound. That's the lower bound. The upper bound, well, there is no real upper bound, and so what we're going to do is we're going to say it's infinity. But the calculator does not deal with infinity very well. Actually, it just doesn't deal with infinity at all. So instead what we're going to do is we're going to type in normal CDF. For our left bound, we'll do negative 1.23. And for our right bound, we're just going to do a very large number. We could do something like 10 to the 99th. And then we'll enter our mean and our standard deviation. We're doing 0 and 1 still. I guess I'm still doing a standard normal. So let's see what that looks like. The calculator's way over here. So I'll do normal CDF. Oops, what am I doing? Went way past it. Normal CDF, we're doing negative 1.23 as the left bound. So negative 1.23 is the left bound, 10 to the 99th, so I'm going to do an exponent by doing this button right here, 10 to the 99th, comma, oh, you can't even see, I was doing 0 and 1 there, 0, 1, hit enter, and we get 0.8906. So that's if I wanted to find the area to the right of a particular value. If I want to find the area to the left of a particular value, let's say from to the left of z equals, well, I'll call that 0.5. Then my region is over here, and now the z equals 0.5, you'll notice this is on the right. So if I want to do the left, on the left over here, well, the left goes off to infinity. Well, except it's infinity in the negative direction. And so what I'm going to do here is a normal CDF. For my left bound, I'm going to do negative 10 to the 99th. And for my right bound is 0.5 and 0, 1 again. So normal CDF. Negative 10 to the 99th, 0.5, 0, 1. Hit enter, and we get a probability of 0.6915. So that's how we use the calculator to do the normal, to find the probabilities either to the left or to the right. Now, the other thing you're going to need to be able to do on this calculator is to do what's called, well, an inverse norm on the calculator. So if we had a region like this, and I said there is, I want 0.75, if I want 75% of the area to be to the left, and let's say, what is z? Well, in this case, I'm going to use what's called inverse norm. So inverse norm on the calculator, it's located in, I think it's the next entry. Yeah, inverse norm, right after the CDF. So we'll do inverse norm, and then I'll go ahead and enter what is the area to the left, my mean, and my standard deviation. So that's how I'm going to use inverse norm. The area to the left, in this case, I'm saying the probability of getting a value less than 70 or less than z should be 0.75. Which means the area to the left should be 0.75. And since I'm saying z, that means my mean is 0 and my standard deviation is 1. If you wanted to do a different mean or different standard deviation, you could plug those in there. But we get a, this is approximately 0.674, whatever, I'll go 4 decimal places, 0.6745. And if you wanted to verify this, just to kind of make sure that these actually do go the opposite way. If I wanted to say, okay, if this is z equals 0.6745, and then I said the area between negative infinity, or negative 10 to the 99th, and z equals 67.45, that should give me 0.75. So I'm just going to quickly verify that. Distributions, we get normal CDF. I'm going to say from negative 10 to the 99th up to 0.6745 with a mean of 0 and a standard deviation of 1, and we get really, really close to 0.75. So you can see they do kind of go opposite directions from each other. The inverse norm and the normal CDF are inverse operations in a sense. Now, you can make this a little bit more complicated. What happens if you wanted to find the area, you had something like this, and you wanted to find the area to the right, or a z value such that the area to the right was a particular value. So if I wanted to say, okay, what happens if I want this area to be 0.6? This inverse norm only tells us the area. This area right here is to the left. It's always to the left. So if I wanted to figure out what the area, what the z value is such that the area to the right is 0.6, well, I need to use my complement rule to say that means the area over here must be 1 minus 0.6, which is 0.4. And then I'll do inverse norm of 0.401. And that would give me whatever number. Negative 0.2533. You'll notice that this is less than 0. It's negative. That actually is expected because you can see I have more than half of the area to the right of my line less than half of area to the left, which means I should be to the left of the mean, in other words, less than 0, since my mean was 0 in this instance.